Hey everyone, Harsh here. In our journey through system design, we have tackled some big ideas, things like horizontal and vertical scaling, microservices, and building some fault tolerant systems. But today we are going to zoom into a single fundamental decision that underpins all of those concepts. It's a choice that dictates how your application behaves, scales, and survives failures. Is the choice between building a stateless or a stateful system. When we talk about state in software, we are really talking about memory. It's any piece of information a server holds onto from one moment to the next to provide a continuous experience. If a server remembers something about you, what you put in your cart, the fact that you have logged in, what level you are in the game, that's state. Let's make this concrete with an e commerce website. Imagine you do three things. You log in, the server creates a session for you. You browse and add a couple of books to your cart. The server remembers these items. You click checkout, the server knows who you are and what is in your cart to begin the payment process. Each of these steps depend on one before it. The server needs to remember your login and your cart contents. That memory is application's state. Without it, every single click would be like visiting the website for very first time. Your cart will always be empty and you will never stay logged in. Is the glue that holds a user's journey together. So, if state is memory, a stateless system is like an amnesiac. It has absolutely no recollection of past interactions. Every single request you send it to is treated as a brand new event, completely independent of any other request. The perfect analogy here that comes to my mind is a vending machine. You put your money in, you press a button, and you get the snack or a drink. The machine doesn't know who you are or what you have bought 5 minutes ago. Your next transaction is a completely fresh start. In the world of web services, this means the client has to provide all the necessary context with every single request. Think about a REST API. You don't just ask for /me. You send a request to /me and include the authorization header with the token. The token contains everything the server needs to identify you and process your request. Once the server sends back your profile data, it wipes its hands clean. It doesn't remember your token or who you are. The next time you call, you have to present your credentials all over again. So, why would we want our servers to be so forgetful? Well, this amnesia is actually a superpower when it comes to scalability and resilience because no server holds any unique user data. Every server in your fleet is a perfect clone. This is a load balancer's dream. It can send your request to server 1, your request to server 4, and after that request to server 2, and it doesn't matter because each server has everything it needs from the request itself. This makes horizontal scaling, just adding more servers, incredibly simple. Now, what happens if suddenly server 3 catches on fire or some earthquake comes and it goes offline? Nothing. The load balancer just stops sending the traffic there. The user's next request goes to another healthy server and their experience is completely uninterrupted. No session lost, no data gone. This is the fault tolerance at its finest. On top of that, your server code becomes simpler, and because the responses are predictable, they are highly cacheable. This is why a vast majority of web APIs, especially RESTful APIs, are designed to be stateless in nature. The benefits of large scale systems are just too good to ignore. Statelessness comes with its own set of trade offs. First, your requests get chattier. Since your server remembers nothing, the client has to constantly reintroduce itself. This means sending the authentication token, maybe a unique card identifier or any other context with every single API call. This adds a little bit overhead to each request. But bigger point is the state doesn't magically vanish. It just gets outsourced. You have made your application server stateless, but the state itself is now someone else's problem. Usually, that someone else is either the client itself, storing the data in browser cookie or local storage, or more commonly in large systems, a dedicated external state store. This could be a database or an in memory cache like Redis. So you haven't eliminated complexity, you have just moved it. Now, instead of managing state on your app server, you have to manage a whole separate system for it, which has its own operational costs plus failure points. Now, let's talk about stateful systems. If a stateless server is amnesiac, a stateful server is like a helpful conversation partner. It remembers the context of your interaction. Think of visiting a bank. You walk up to a teller, show your ID once, and the rest of your conversation, they know who you are. You don't have to show your ID every time again to ask if you have made a deposit or a withdrawal. A stateful server works in the same way. When you log in, it creates a session for you and keeps it right there in its own memory. It sends you back a small identifier like a session ID or a cookie, and for every subsequent request, and the server says, "Ah, yes, I remember you. You are Harsh, and you have all these items in your cart." The server maintains the state of your session from one request to the next. The primary advantage of a stateful design is efficiency and simplicity, at least from the client's perspective. The requests are much smaller and cleaner. The client just needs to send a tiny session cookie and that's it. All the complex state, the user profile, permissions, shopping cart data is handled on the server side. This can also lead to better performance for certain workloads. Reading from the server's local RAM is also one of the fastest operations you can do. It's orders of magnitude faster than a network round trip to an external DB or a Redis cluster. For applications that require extremely low latency, like a real-time multiplayer game server tracking players' position, keeping the state in memory is massive performance win. However, the drawbacks of stateful systems are significant and they all revolve around scale and failure. Remember how a load balancer could send requests anywhere in the stateless world? That's not possible here. If user X's session data is stored in memory of server 1, then the load balancer has to be configured with sticky sessions to ensure all user X's future requests are stuck with server 1. This makes the load distribution uneven and complex. And the failure scenario is catastrophic. What if server 1 crashes? Every piece of session data on that server is gone. Every user connected to it is immediately logged out, their shopping carts are emptied, and their work is lost. Unless you have built a very complex state replication mechanism, there is no graceful failover. This fragility is why pure in-memory stateful architectures are rarely used for large-scale general-purpose web applications today. The risk is just too high. So if stateless is scalable but dumb and stateful is smart but fragile, what is the solution? The answer used by nearly every major tech company is a hybrid approach. In system design, it's always about hybrids. They combine the best of the both worlds. Here's the architecture. You design your application servers to be completely stateless. They are perfect, interchangeable clones. However, you don't throw the state away, you externalize it into a dedicated centralized system that is built for speed and fault tolerance, like a Redis cluster or a highly available database. Now, look at the flow. A user's request can hit any app server. The server then makes a quick network call to Redis to fetch the user session's data. This does its work, maybe updates the session and writes it back to Redis. With this model, you get incredible scalability and resilience of a stateless architecture because any server can die without affecting its users. But you also get the rich, continuous experience of a stateful system because the state itself is safely preserved in a central location. This is a dominant pattern for building modern cloud native applications. Let's make this real by looking at two giants of the web, Netflix and Amazon. Both operate at large scale that is almost unimaginable to a normal person, and both rely heavily on stateless servers and externalized state pattern. When you browse Netflix, the microservice that fetches the movie catalog for you is stateless. If the server instance fails, another one just takes over. But your viewing history, the fact that you have been 42 minutes into a movie, is lost. Why? Because the state is stored safely in a massive distributed database like Cassandra. It's the exact same story with Amazon. The servers that show you product pages are stateless, but your shopping cart is not stored on that server. It lives in a highly resilient database like DynamoDB. That's why you can add an item to your cart on your phone and it is still there hours later when you log into your laptop. The state is centralized and not tied to a single fragile server. But what about the cases where you can't be stateless? A perfect example is a messaging app like WhatsApp. Think about the requirements. The system needs to know in real time if you are online. It has to maintain a constant open connection to your phone to push messages to you instantly. This is the definition of a stateful interaction. The stateless APIs, where your phone asks any new messages here from me, every second would be incredibly inefficient. So WhatsApp's architecture embraces statefulness. They have a layer of servers whose entire job is to maintain a persistent stateful connection with millions of devices. When you send a message, it goes to one of these servers, which then places it into a durable message queue, another stateful component that guarantees delivery. The server then finds the recipient's connection manager and pushes the message out. The key takeaway here is while stateless is default for scalability, some problems are fundamentally stateful in nature. For these, the engineering challenge becomes how do we manage and replicate the state reliably so that if a server crashes, the user's connection or messages aren't lost. That's a much harder problem to solve, and that's why companies invest so much into these complex stateful platforms. Alright, let's do a side by side comparison. When you look at this table, the pattern becomes really clear. Stateless systems are champions of scalability and resilience. They are simple to manage at server level and are go to for most modern web services like REST APIs. Their main trade off is slightly more work for the client and need for external place to put the state. On the other hand, stateful systems win on raw in-memory performance and can lead to simpler client logic, but it comes at a huge cost. They are fragile and incredibly difficult to scale effectively. This is why you only see them in very specific, latency specific applications like real time gaming or chat servers. And as we have seen, the industry has largely settled onto this modern hybrid approach, which has the best of the both worlds and foundation for almost every large scale application you see. So, after all that, which approach is better? Well, the most important lesson in system design is that there is rarely a single best approach and a single best answer. It's always about choosing the right tool for the right job. However, there is a very strong default choice for modern development. Start with the stateless application tier. It forces you to think about scalability and resilience from day one. By designing your servers to be interchangeable cog in a machine, you are building a system that can grow and survive failures. The next step is to consciously externalize your state. Don't just let it disappear, move it to a system designed to manage it. Like Redis for speed or a durable database for safety. And finally, only embrace a truly stateful architecture when the problem domain absolutely demands it, like real time application constraints of WhatsApp. And when you do, go in it with your eyes open, knowing that you are taking on a significant challenge of managing that state reliably at scale. Hey, if this video helped you understand this topic, don't forget to like and subscribe. You can also drop your suggestions down in the comments about the improvements and the topics you would like me to cover next. Till then, thanks for watching, and I will see you in the next one. Peace.